Welcome back to lesson 72. It's another average activity over here, and we're going to try to select or justify which might be the better average to use. So while I'm working, look to see how I demonstrate that I can calculate various averages, so mean, median, and mode, how I describe the data sets using information, whether it's from the graphic itself or from my statistical information, my data, and how I make decisions on which average might be the best one to represent the data. The principle of setting up after-school activities: find the averages for the data set. Which average best describes the typical age of students in the after-school program? He will use this data to set up homework helpers. What is the typical age of students in after-school? So just looking at the data, you can see it absolutely peaks here at 11 and then starts to trail off. So there's a skews to the right, but you can see our cluster happening here. So the typical age will definitely be on the younger side, closer to 11, 12 than to 13 and 14. That's just looking at our numbers here. All right, so which are the easiest data sets to write down? Mode is very easy to see. It's our peak. So 11 years old would be the mode. Our range, our data goes from 14 to 11. So 14 minus 11 is 3. So that's our range. For our median, we have, let's figure out what our n is. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So, we have an even set. So we're going to look for the 8th and 9th number. I'm just going to put this here so you can see it. N equals 16. So half of 16 will be 8. So I'm going to look for the 8th and 9th and find the average if they're different. 1, 2, 3, 4, 5, 6, 7. Here's 8 and here's 9. They're both in 12. 2, 3, 4, 5, 6, 7, 8. Yep. So our median is 12. So far, our mode and median kind of show what we were looking for. Half the numbers, half the kids are 12 or less, and the other half are 12 to 14. So we can definitely see the cluster, and we see it over here, and our mode is 11. Let's calculate our mean, which would be an even share. I don't think that would be fair in this one, in this case, but let's see what comes up. So I'm going to, for 11, how many sets of 11 do I have? 1, 2, 3, 4, 5, 6, 7. Plus, how many 12s? 1, 2, 3, 4, 5. Plus 3 13-year-olds, plus a 14-year-old. So we have 77 plus 60 plus 39 plus 14. I'm going to use my calculator to just simplify these. 77 plus 60 plus 39 plus 14. And that gives us a total of 190. And we're going to divide that by 16. And that gives us an average age of 11 and 875. So this rounds up to, let's round it to the nearest tens place, 11.8 years old. These are all our ages. Okay. So, using mode, median, and mean, which makes the most sense? So all of them are actually very close together. So our mode and our mean just means 11 going towards 12. That makes a lot of sense. I could actually use the mean, median, or mode to justify my answer. I'm actually going to use the mean in this case because it suggests at 11.8 years old that they can be 11 close to 12 years old. The typical age in after school is 11 or 12 years old. Mean is appropriate. $11.8 years. Okay, and that just makes the most sense. More than half of the kids are between 11 and 12 years. So mean makes sense here, 11.8. I thought it was going to be a little more skewed, but since most of our kids are actually 11 and 12, the mean was much lower than I thought it was going to be. Hit pause and jot this down into your notes. The test scores of students in Mr. Duffy's class is shown in the line plot. He wants to know the typical test scores in his class, calculate the averages as well as the range. So the easiest ones again are mode. Mode is very easy to see. It pops right up. Our range is from 100 is the maximum and 60 is our minimum. So I know my range is 40. You may be asking, why don't I do 60 minus 100? It's because 60 minus 100 will give us a negative number. So I do maximum subtracting and then the minimum. All right, median, what's our N? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so our N is equal to 18. So I want half of that is 9. So I'm going to look for the 9th or 10th number. Hopefully they're the same. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's 9 and here's 10. They're both in 85. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep, 85 is the median. I didn't have to do anything. We're both 85. So let's calculate our mean now. Let's find the sum. 60 plus 2 times 75 plus 4 times 80 plus 5 times 85, 3 times 90, 2 times 95, and plus 100. All right, let's start simplifying this out. 75 times 2 is 150, so 60 plus 150 plus 4 times 80 is 320. 5 times 85 is 425 plus 270 plus 190 plus 100. Oh God, there are 18 numbers here. There's so many. Okay, so we added all our numbers together and we have a sum total of 1,515, and we're going to divide this by 18. And so the average score in class, when we divide by 18, is 84.166. So I'm just going to round that to 0.1700s. And notice all our data, again, is very close together. Our mode and median are exactly the same, and our mean is very close as well. So he wants to know the typical test score. The typical score is 85 according to mode and median. More precisely, the mean is 84.17. And notice how that got pulled. Like, we still have a ton of kids, half the kids scoring very high, but look at the impact of that one student who got a 60 and how much that outlier pulls away from the rest of the cluster of the data. And that's really important because we have a wide range of numbers here, super wide range. And that's important to know. It tells us that our numbers are really spaced out. And in this case, if we have a wide range but a higher median, we can look at our data to see, like, we possibly have one outlier that's pulling all the numbers across, and that's bringing down the average. That's it for today, Math Marbles. Hit pause and jot this down in your notes. And get some practice. Remember to keep your work organized and take time or work with a partner as you're adding and calculating averages, especially mean. I'll see you in the next lesson, Math Marbles. Take care.